Video 66 is going to take a look at simultaneous equations again, but we're going to see what happens when we evolve a quadratic equation as well. So for instance, here we've got two equations, y equals 2x minus 11, and x squared plus y squared is equal to 25. So how do we solve them? Well, our first job is that we are going to combine the simultaneous equations with factorizing the quadratics. So the work we did on factorizing quadratics, we're going to use that in order to solve, to change this equation down here into something we can solve. So firstly then, if I want to change the y into a y squared, and notice how by here we've got a y squared, so if I can change this into a y squared, I'll be able to substitute this value into this equation. So I have to square everything that y is worth. So in this case, y has the value of 2x minus 11, so y squared would be 2x minus 11 times 2x minus 11, or in other words, 2x minus 11 squared. Notice how it's not 11 squared, it's 2x minus 11 squared. And that's why I've put the brackets around it, because it's easier to remember that we're squaring the whole of this equation, not just part of it. So now I've got the value of y squared, I would be able to substitute this 2x minus 11 squared into the second equation instead of the y squared, because I know that that is the value of y squared. So our next job would be, if you remember that when we used FOIL, we won't be able to solve it when we've just got 2x minus 11 squared. So we're going to expand that out by using FOIL. So we're going to multiply 2x minus 11 by itself, which then involves looking at the firsts. So we got 2x and 2x, which are the first terms in the brackets, and 2x times 2x will give us 4x squared. The outsides, which will be 2x times minus 11, or minus 22x. The insides, which is a minus 11 times 2x, or minus 22x. And the last, which will be minus 11 times minus 11, or 121. So in other words, y squared is equal to 4x squared minus 22x minus 22x plus 121. And if you can't remember what I've done by here, have a look at the video on FOIL, just to remind yourself of how we expand out these equations when we're multiplying two formula together. Simplifying that down then, the 2 minus 22x's come together and we've got this equation by here. So going back to the equations that we're working with, I can now substitute this value of y squared, 4x squared minus 44x plus 121, the expanded 2x minus 11 in. And so but before I'm going to do that, I'm going to rearrange it so that this equation also has just y on one side. I can plonk this in straight away and have x squared is equal to this, but I've just rearranged it first. And now I can substitute it, so the y squared is swapped for all this value by here. I've taken the y squared out and put this in. So now I've got 4x squared minus 44x plus 121 is equal to 25 minus x squared. I'm going to move the x squared over to the other side to put the x squareds together so I can merge these two like terms. So it becomes 5x squared minus 44x plus 121 is equal to 25. And then remember that when we're solving quadratic equations by factorizing, we need a 0 on one side. So I'll move the 25 over and it becomes 5x squared minus 44x plus 96. And now we've got a quadratic equation. And if you remember, with factorizing quadratic equations, we can then go on to solve this. Now, I'm doing another video on harder quadratic equations, which will take this into account. So have a look at that one. It'll actually be coming up later. But have a look at that one if you can't follow the next bit I'm going to do. So we're going to factorize the quadratic. Remember, this is also in factorizing quadratics. And when we do the first, we're going to have 5x times x, which will give us 5x squared. There's no other combination that can do. If we did, say, 3x times 2x, that'll be 6x squared. If we did 2x and 2x will give us 4x squared. You can only have 5x times x to give you x squared. So we know that one of these starts is 5x, and we know that the other start will be x. Doesn't really matter which way around you put it. Next, I've got to look at which numbers multiply to give you 96, just like we do when we're factorizing quadratics. So we've got 1 times 96, 2 times 48, 3 times 32, 4 times 24, 6 times 16, and 8 times 12 all give you 96. Helps sometimes to write this, write the numbers out so you remember which ones you're working with. Where it gets a bit more complicated is that we have to multiply one of those numbers by 5. And the way to think of this is that if the number is placed by here in the second bracket, when we multiply these two numbers together, doing the outsides, this number will have been multiplied by 5. So the next thing you want to do, once you've, I'll just go back to the previous slide. Once you've listed all these numbers, list them all again with either the first number multiplied by 5 or the second number multiplied by 5. So for instance, the first was 1 and 96. Well, that's either 1 times 5 and 96, 5 and 96, or 1 and 96 times 5, which is 480. The next numbers were 2 and 48, so that's either 2 times 5 is 10 and 48, or 2 and 48 times 5, which is 240. After that, we had 32 times 3 was 96, so it's either going to be 3 times 5, which is 15, and 32, or 3 and 32 times 5. So it essentially doubles the number of combinations that you've got. And we've now got all these different combinations of numbers that we work with. These are the ones then that we can now pick and choose from to look to see which will give us the number 2 if, the number in front of the x in order to solve our answer. So the answer that we needed, if we go back to our original equation, apologies, I don't know what I didn't write it down. Our equation was 5x squared minus 44x plus 96. So we said that the numbers we found multiplied to give 96, but the numbers added together have to give us minus 44. And if you look at all those combinations, 20 and 24 will give you 44. So 20 and 24 will be the two numbers that we are going to use, because minus 20 and minus 24 will give us minus 44. Remember that I multiplied this number by 5. So I go back and divide it by the 5, and the numbers I should be working with are 4 and 24. So the 4 has to be opposite the 5, so it's both the outsides, and the 24 has to be on the insides. So now we're going to have, when we do FOIL, the first 5x times x will give us 5x squared. The outsides, 5x times minus 4 will give us minus 20x. The insides, minus 24x, and the lasts will give us 96. So altogether we'll have 5x squared minus 44x plus 96, which is the equation that we wanted earlier on. So we know that either 5x minus 24 is 0. In other words, we move the 24 to the other side, 5x is equal to 24, and then divide by the 5 to get x on its own. So either x is 4.8, or x minus 4 is 0, so x is equal to 4. So our two options are either x is equal to 4, or x is equal to 4.8, but we aren't done yet. We can now take one of the equations and substitute the values in. So 4, instead of putting the x in, I'm going to substitute the value of 4 in, and we got 4 squared plus y squared equals 25. This is one of the equations that we started off with. Now there's 16 plus y squared equals 25. Move the 16 to the other side. Y squared is equal to 9. X is equal to 3 or minus 3. So either y is equal to 3 or minus 3. So x was 4 and y was 3 or minus 3. Substitute in the other value, 4.8 squared plus y squared equals 25. 23.04 plus y squared equals 25. Y squared equals 1.96. Square root them. Y is either 1.4 or minus 1.4. And now we can check by putting in the values. If we do 2 times, we said x is 4, and y would be either 3 or minus 3. So 2 times 4 is 8. Take away the 11, just like in the other equation. 8 minus 11 is minus 3. So one of the possibilities is that x is 4 and y is minus 3. A second possibility is that we put in substituting 4.8. So 2 times 4.8 minus 11, which is going to be 9.6 minus 11, which is going to be minus 1.4. So either x is equal to 4 and y is equal to minus 3, or x is equal to 4.8 and y is equal to minus 1.4, and both of those answers will work for the simultaneous equation with the quadratic. Probably the most difficult thing you can do in simultaneous equations. Remember to look at the harder harder factorizing quadratics video, and look at the factorizing quadratics video, because this one might have been a bit too hard for you and too quick otherwise. But once you got the hang of those two videos, you can go on to solve the equations in this one.